In this video, we're going to continue topic 8.7 and 8.8, which is about cross sections. And we're going to work with example 1, and we're going to work with a triangle. What the base of the figure is a triangle. So find the volume of a solid in which the base of the region is bounded by these graphs. So before we do anything, let's go ahead and graph those graphs. This could be rewritten as 1 minus 1/2 x. So your y-intercept is 1. And my slope is down 1 over 2. I'll do that a couple times, and I'm going to graph that line there. Okay, and then I'm going to graph the other line, which it's the same thing. My y-intercept is -1, but this time my slope is up 1 over 2, so it looks like they cross there. And then x equals 0 is also the y-axis. So basically the shape we're using as our base is right in here. It's saying in the first one that the cross sections, or in part A, that the cross sections are perpendicular to the x-axis are squares. So I would use my square formula, but in order to use my square formula, I need to know what the length of my side is, or the length of my base is. So what I'm basically looking at here is how do I get from this to from here to here? And really, it's just the area, right? It's going to be the top curve minus the bottom curve. Well, let's set that up. Instead of calling it area, we're going to call it a length of a side. Length of side. So it's going to be the top, which is the blue one, which is the 1 minus, I'm going to write it as 1/2 x. And then we're going to subtract the bottom one, which was the green one, which is in parentheses -1 plus 1/2 x. Right, I'm going to distribute that negative, so it's going to go positive, negative. And then when we combine like terms, I get 1 plus 1, which is 2, and then -1/2 x and -1/2 x. -1/2 and -1/2 would be -1 x. So my length of my side is just 2 minus x. And I could use this length of a side whether it's a square or a triangle or a rectangle or a semicircle. That's the length I would use for the side. All right, so in order to get the volume, the next thing I need to do is how do I get the area of a square? So I'm going to get the area next. So the area would be 2 minus x. So the area of a square is just side squared. So side squared. So this piece here represents the area of a square. We know in order to get volume, we have to integrate that area. And then we have to figure out where we're going to and from on the x values. We happen to have the graph, so it's really easy to read off the graph this time. I'm starting at x equals 0, and I'm going until x equals 2. So I'm going to go from 0 to 2. Now we're going to integrate this just like we've integrated everything else before. Before I integrate, I'm going to FOIL this out. So I'm going to figure out 2 minus x times 2 minus x. So I'm integrating from 0 to 2 of 4. 2 minus x, or 2 times negative x is negative 2x, and I have that twice, so I get negative 4x. And negative x times negative x is x squared, and then dx. When we integrate 4, we get 4x. When we integrate negative 4x, we get negative 4x squared over 2. And when we integrate x squared, we get x cubed over 3, and we're going from 0 to 2. I'm now going to plug in my 2. So let's see, 4 times 2 is 8. These I could cancel, 2 into 4 twice. So I've got 2 squared is 4. Times 2 is 8, and there was a negative there. And then 2 cubed is 8 over 3. And then I put in the 0, and I would get minus 0 on all of those, right? They'd all be zeros. It looks like my 8s cancel, so my final answer on this one is 8/3.